on stage Mr. Ritesh Hegde. So let me introduce him first. He has over 15 years of experience in technical support, project planning and execution, implementation and development. Ritesh has built a solid reputation for delivering optimal solutions in IT infrastructure, MS Azure Cloud Services, Amazon Web Services, and of course, Google Cloud Services. He has a proven track record of success in lift and shift migration of on-premise web applications to the cloud, creating SOPs, POCs, as-builds, HLLDs, LLDs, TDDs, and delivering Microsoft Azure training to both the corporate clients and student groups. There is a long list for him. So let me welcome him on stage. He is currently the Senior Staff Engineer, Platform Engineering Cloud from SPH Media, and his topic is on Terraform, leverage IAC to deploy infrastructure on the cloud. A big round of applause for Mr. Ritesh Hegde. Welcome, sir. Over to you. After this, we'll definitely break for lunch. Thank you.
All right. Thank you very much. Good afternoon, everybody. I know you guys are all hungry and you probably be looking at when will this be over that you can break out for lunch. So don't worry, I won't take much time. It will be hardly 20-25 minutes. And this would be a technical session. I won't be talking much about what is when and how. So this would be more of like a technical session and a demo at the end. So brief introduction about me. My name is Ritesh Hegde. I am Senior Staff Engineer Platform Engineering Cloud at SPH Media. And my credentials, I'm certified in all three public cloud, major public cloud, being MCT since 2020 till 2023. I'm a community lead for HashiCorp user group, Singapore. I'm also lead for two other community, that is Kubernetes Singapore user group and Azure Community Service. A disclaimer that the thoughts and views expressed are my own and does not represent my organization or HashiCorp. So if you have any feedback or you want anything to be changed, please reach out to my ritesh@rhegdecloud.com and I will do the needful. So my topic is Terraform leverage infrastructure as code to deploy infrastructure on cloud. So why do we need, or why was there a need to have infrastructure as code? Because we already had a portal, we already had command line. So why there was a need, to have an infrastructure as code? So challenge was manual provisioning was very slow and cumbersome. Now someone will argue, okay, fine, even though the portal was quite tedious, you have to log in and follow a certain step, but we had a command line, agreed. But let's say you are in hybrid model. You have AWS, you have GCP, you have Azure, you have Oracle. So you need to learn 4 more CLIs, right? So to overcome that, this kind of challenges, there was a solution that was to automate infrastructure provisioning on any cloud. So Terraform, HashiCorp came with a tool called Terraform. And this Terraform is an open source. It has an enterprise, but I would not talk about enterprise because I'm not selling it. This is just an informative wherein I would be talking about Terraform as an open source. And with Terraform, it's a cloud agnostic tool. And when I say it's cloud agnostic, that means Terraform can work with any public cloud provider as well as with on-prem as well. So you don't need to worry about learning 4 different CLIs. One language, it's done. So as I said, why infrastructure as code and why Terraform? With Terraform, you can manage infrastructure on multiple cloud platforms. The HCL, that is HashiCorp language, developed on Go, is quite human-readable configuration to write your infrastructure. You have Terraform states. Terraform state is a single source of truth for Terraform. And you can commit your configuration to version control, and you can collaborate with your team members. So there are lots of advantages. So as you can see, you can standardize your deployment. So infrastructure as code, you can plan, apply, and as I said, you can do it for multiple cloud, like all possible cloud. You can do for Kubernetes, even for VMware. And one more thing to highlight here. So when you define resources in a block in Terraform configuration, it need not be in a flow wherein like you want first the resource group to be created, or let's say you want A to be created, B to be created, C to be, no. You just write your file, you write your configuration. Terraform will understand what's need to be created when, and it will accordingly do whatever is needed. So you don't need to worry about that. So to deploy an infrastructure of Terraform, what you need? Scope. Identify your infrastructure of your project. That means what you want to do. You want to deploy a Kubernetes cluster, you want to deploy a multi-tier web architecture, or whatever. You identify the scope of your project, the resources, author them. Then start writing the configuration file, the TF file, like main.tf, variable.tf, version.tf. Once you have all this ready, then initialize. Initialize is where Terraform will start downloading its Terraform plugins and everything from the Terraform registry, so that it can execute the plan and it can execute the apply to make the plan changes. As I said, it also helps you to keep a track of your changes of your infrastructure, and that is done by terraform.tf state file. So terraform.tf state file is, as I said, single source of truth for Terraform. Now, yeah, as I said, it's also good to collaborate, because we are doing that in our organization as well, wherein we collaborate with the version control system GitHub. And you can see it also allows, so this Terraform cloud is free up to 5 users. So it's not it has an enterprise version as well, but I'm not going to talk about that. But you have a Terraform cloud free up to 5 users. So if you have a small organization and you want to leverage Terraform cloud, go for it. It's really good. Okay. And you can also connect the Terraform cloud to GitHub, version control system like GitHub, GitLab, and different configuration. Okay. So this is basic about what Terraform is and what it can do, or how it can help you within your organization to collaborate and do things with your team. Now we will move on to a technical part. So this would be more of like how to install, what all things are there in Terraform. So if you want to install a Terraform, there are 4 different ways. So there's a manual installation. There is for Mac OS and Windows and Packet Manager. So it can be installed on all the operating system that you have. So build the infrastructure. So before building infrastructure, so you need to have Terraform CLI. You need to have one of the cloud, whichever you're working the CLI. Credentials is necessary. If AWS, you need to have IAM user, Azure AD user, And if it is GCP, you need workload identity, G Suite user, or service key and ID. Okay. Then, as I said, you need to write a configuration. So there is a sample of a configuration. How does a configuration look like for creating a simple one single EC2 instance in AWS? We will talk about that later. And yeah, one more thing, each Terraform configuration must be in its own working directory, okay? Yeah, so when you build a Terraform configuration file, you have something called as Terraform block. So Terraform block is in curly brackets, okay? Whatever is defined within the curly brackets is Terraform, it's called a Terraform block, like provider block. You can call it a provider block, you can call it resource block, data block, or locals block, or whatever block. Whatever block you define in Terraform configuration is called a Terraform block. Providers block is where you specify the service provider. For example, let's say you want to deploy a resource on AWS, so you have to provide AWS provider. If you want to do it on Azure, you have to provide Azure RM provider. And if it is Google or VMware, accordingly you have to provide them. And the third part is resources. So resources is actually what you would like to deploy on your Terraform, on your cloud using Terraform. So it could be any physical resources like EC2, storage, or something like that, or it can be logical resources like Heroku or Lambda application. So when you write Terraform configuration file, then Terraform help means there is a command called Terraform FMT. Okay, Terraform FMT. Terraform FMT, what it does? Terraform FMT. So Terraform FMT hyphen recursive. So what it will do? You can either do Terraform FMT. So the directory under which you are doing Terraform FMT, it will look for all the TF file. It will format them to the required indent that is needed for the configuration file to look good, okay, and Terraform to understand. Now let's say you have multiple folders within the folders. So you do Terraform FMT space hyphen recursive. So it will look for all the Terraform TF file within your directory, and it will format it to the indent level which is required. Okay. Yeah, after format there is one thing called validate. Now the difference between validate and validate, what it will do after FMT validate will check that the syntax or the configuration that you have mentioned within the block, is it valid? Okay, is it valid? If it is not valid, it will give you an error and ask you to rectify them. Okay, so that's a very good way that when you are doing it, try to use Terraform FMT and Terraform validate before going for Terraform plan or apply. So that gives you a very good understanding about how your infrastructure is and what all changes you need to do. Terraform plan. So it's an execution plan. So when you do Terraform init and Terraform plan, what it does is it creates a plan. Now plan is where it will read the current state file. Means let's say I'm creating an EC2, for example, okay? And so I'm creating it for the first time. So the first time I will initialize, I'll run the plan. So plan, what it will do, it will try to see if there is any state file available for that. If it is there, it will look into that state file. It will check for the current configuration present in the state file. And then it will check the configuration that I have provided. If it matches, it will say no configuration changes, no changes required. Okay, but let's say I added one more instance. Okay, I added one more instance. Then it will verify with the Terraform state that, yeah, there is one more instance that has to be created. So it will show you in the plan that one more instance will get created. It won't create, it will just show you, okay? That's called plan. And as I said, Every action that is taken in Terraform, it goes to the state file and it checks the state file for the current state of the infrastructure. Apply. So difference between plan and apply, they are, the only difference is when you do apply, it actually make the changes. Okay. So it will ask you, do you want to make changes, yes or no? You have to give yes. Once you give the yes, it will start building your infrastructure and it will start provisioning the resources in your cloud. And then this is the best part, or like destroy, I mean, don't do it on your production. But yeah, if you want to, you have deployed infrastructure and you want to delete them in one go, rather than selecting one by one each and every application or each and every resources, you do Terraform destroy. Terraform destroy will look again at the state file and it will start, it will get the information, it will understand that these all resources were created and I need to delete all these resources. So entire infrastructure you can delete just with one click. So state file, yeah, as I said, this is most important file, your state file. And as a best practice, state file should not be stored locally. So if you're doing development or testing for your own self, storing it locally makes sense, it's fine. But if you're collaborating with your teammates or you're in an organization, it's always better to have the Terraform state in backend remote. Okay, it could be either your version control system, it could be any storage. If you prefer AWS, put it on S3 bucket. You prefer Azure, put it in Azure storage. If you prefer GCP, put it in cloud bucket. Whatever you like, but keep it remote. And if you like to use Terraform Cloud, yeah, keep it on Terraform Cloud, the TF state. And you should always make sure that it is secure and you have restricted access, because any changes to the Terraform state could mean a potential damage to your infrastructure. Okay, so you have to make sure the Terraform state file is secure and not everybody has access, and who has access should have a valid access. So today I would be showing you two demo, okay, exactly 15 minutes. So these two demos would be one is this wherein I would be using GitHub Action Runner. Remote state file would be stored in Terraform Cloud, free, and we will have a Amazon EC2, a simple web server pushed into AWS, and we'll try to access that web server. And second demo would be, now the first demo, the difference between these two is the first demo I would be showing you guys how state file looks into Terraform Cloud. And in second demo, I will show you how does it look into a bucket, Azure storage. Okay. Now it's time for demo. How can I keep the mic? Don't have. Okay, I'll manage. Thank you. That's interesting. Am I audible to you guys? Can you hear me? Thank you. Thank you. So I have two repos that I have already created here. One is AWS demo and Azure demo. So first we'll go with AWS demo. So I'm currently in AWS demo. Okay, I do git branch. So currently I'm on main branch. Okay. So I'm creating a branch created. So this block is already created here. If you see, I have created a workflow. So there is apply and plan workflow, secrets, TF API token is provided. The workspace and config directory, all the details have inbuilt provided, so I do not have any issues while I'm deploying this. So I have a main.tf file. I'll just uncomment it. So if you can see in this configuration, I have a data block. So as you can see, between the curly bracket, it starts here, it ends here. Within the curly brackets, there is something called as data. So I'm feeding data into Terraform. I'm telling Terraform that AWS AMI should be Ubuntu. It should be most recent, true. And then I'm also telling that what values, when you're looking for it, filter to the values where it will be Ubuntu Focal 20.04. So version should be 20.04 at the end star. Virtualization type, HVM, and owner, so canonical. So basically I'm telling, oh, okay. So is that better? Okay. Now? Okay. And there is another block called resource. Under resource block, what I'm doing is I'm actually defining, and I'm telling that I want an AMI data.aws AMI Ubuntu ID. So what I'm telling is I'm telling the Terraform configuration that for AMI, go ahead and look at data AWS AMI Ubuntu.id. Okay. Instance type, I want it to be T2 micro. VPC security group ID. So AWS security group web ID is already there. If you can see down, I have mentioned here the security group and the web address. So all the configuration is given, and I have not followed it like first network should be created, subnet or whatever. I just gave them, I dumped it there. Okay. And in the versions.tf, again I will uncomment it. So as I said, I have to give some certain provider. So I'm telling Terraform that when I'm running this, run it against first. Before that, you need to have this provider. So it will download all this provider, AWS. So source will be HashiCorp.aws, and that would be the version. And AWS provider, I'm also saying that it should be US West 2. So I am telling AWS Terraform that create this infrastructure in US West 2 region. Okay. So let's hope the demo gods are happy on me, because it worked yesterday. Hopefully it works today. So let's see. So status 2 modified, I'll add them. Git add, commit them. So usually when you commit, you give a good detailed explanation of minimum, but you should understand what you are doing a commit. And now I do git push. I'll go to my repo, compare and pull request, create a pull request. Now you will see under require approval, the workflow is running. It is running Terraform plan. If I go open, I'll check the Terraform. You can see it shows me what all actions is. Again, I believe it's too small. I hope this is visible. Okay. So as I said, the demo gods are not happy on me. So the Terraform plan errored, giving me some error about so I'll see what is the error. So it's saying an argument of block definition is required. To set an argument, use equal sign. Okay, I understood. Okay. It's a small git add, git commit, git push. So if you see it's the plan is queued. So Terraform plan successful. So if I go here, now I'll merge the pull request. After merging, it will start applying changes to my configuration. If I go here into my workspace, I'll go to runs. Now I merged it, merged successfully. See, now the plan is queued. You can see plan is queued. So after merging, now it is going to again do a plan, and then finally it will be doing an apply. Now I have kept apply manual. I haven't kept it auto. So I need to confirm the apply first. But in your organization, you can keep it auto as well. So it will automatically apply. So if you can see, the plan state that it's going to create 3 resources. Okay. And if you expand, it will as well show you the AMI ID, some information which it has, and some information will be known after apply. So now apply queued, it is running apply. Once this is done, I should see the instances started appearing. Apply running. The instance is up running. Apply finished. Now it has given me this IP. Okay, as I said, it's a web server. Let us see if it is working. It's not yet completely up. Yeah, it's working. So, as you can see, just within like 5 minutes, I was able to deploy the entire infrastructure on a website. Now, yeah, you may say it's very small, it's not that big, but imagine where you are going to do a big infrastructure deployment like 2 tier, 3 tier, and it will take some time for your configuration file to write, start. But the fruits that it will give you later for managing and maintaining it would be worth it. So, can I have 3 more minutes, or it's hard fast? We are done. Okay, since we are running late, I won't be able to show you another one. Now for questions, I haven't prepared for it, so let's go for it. So, is Terraform open source? Who can answer? Who said yes? Oh, thank you so much. Okay, second. If I run Terraform destroy, what will it do? It will create infrastructure or destroy the infrastructure? Thank you guys very much. I don't want to hold you off. You guys can go out for lunch. And thank you very much for being here and supporting me. I hope you like this session. And if you guys want to discuss anything, please come out to me, reach out to me, and I would be happy to discuss with you whatever information I have. Thank you very much. And just before leaving, yeah, I just want to, you removed it. One last. Yeah. So as I said, I'm a Singapore lead for HashiCorp user group. So we are going to have HashiCorp user group meet on 15th August, okay, at SPH Media Auditorium. This is the QR code. Please sign up for the QR code, register, ask your friends to come, because we have very wonderful lineup, 3 awesome speakers who are speaking on different variety of topics. So do come, and food and drink will be provided. And if you guys want to connect me with on LinkedIn, then that is my LinkedIn QR code. You can reach out to me, connect with me, and I would be happy to help. If anything, you can write to me, ritesh@harhegdecloud.com, and yeah, I'll be reached there as well. Thank you very much. Have a good day. It was nice talking with you. Thank you. Bye.
So thank you, and it was a very insightful presentation followed by an hands-on. So thank you so much. And I will take this opportunity to, as Dr. Sharmila, Director of Excellentro, to felicitate him. Thank you so much.